Good morning, class. I want to apologize if those videos were confusing. I wasn't able to make it to the classroom yesterday in order to make the videos, but I was able to go to the classroom today, and I brought home the camera, so that's why it kind of looks like a different background. It's darker. I'm doing this from my house. So to reevaluate what we're doing today, no need to do any of the problems on the worksheet. Just watch what I'm doing, okay? And then just kind of fill in the answers to the worksheet. Well, no, you don't have to do that. We'll just have the worksheet tomorrow about something similar. So this is the equation of tangent lines and normal lines using limits. So a tangent line is, well, we'll do some review here. Say if we have a function like that. The tangent line is a line that touches the function at a singular point, just like that. The normal line is perpendicular to the tangent line. So the normal line would be this in orange. It would be something like that. So we have the tangent line and the normal line. So I wrote down the steps here to find the tangent line. I wrote down the steps to find the normal line. It's really not that bad if I guess it was a little more straightforward than how it was presented. So I apologize for that. This is what we're going to be using to find the slope of the tangent line, and that is the limit as x approaches c of f of x minus f of c divided by x minus c. So the steps to find the tangent line. First step, we need to plug in c to find f of c. So that will be our point that we'll use when plugging in for point slope form. And we'll also need f of c for our slope. And then to use the m-tan, the slope of the tangent, to find the slope. And then step 3, we're going to plug in our points, or our one point with 2 coordinates, and slope into the point slope form, and then we're going to solve for y. Now the steps for the normal line is we need to find the slope of the normal line, and that is just going to always be the negative reciprocal of the slope of the tangent. And then we want to plug in our f and f of c, and it's the same values that we used for the tangent, and then solve for y. So let's take a look at this example here. We're given the function f of x equals x squared minus 5, and we have c is equal to 2. So, step 1, plug in c to find f of c. Well, f of c would be f of 2, wouldn't it? So we plug in, let's see, I'll use a different color here. Plug in f of 2 is equal to 2 squared minus 5, which will give us, see, 2 squared is 4, minus 5 is negative 1. So we now have our point that we'll be using, our c comma f of c, and that is going to be 2 comma negative 1. So this is the point at which we're concerned about. If we're looking up here, it would be this point right here. It's the point of concern that we're where the tangent line touches the function. So now we need to use this mess up here to find the slope of the tangent. So it's going to be, I guess I'll just write it up here just so we can see it. M tan is equal to the limit as x approaches c of f of x minus f of c over x minus c. So let's see, our f of x is this function. So we're going to plug in, let's see, so the limit as x approaches c, and c in this case is 2. So the limit as x approaches 2 of f of x, so that is x squared minus 5, minus f of c. Well, f of c is really f of 2, so that's negative 1, divided by x minus c. So x is just x, and then c is 2, so x minus 2. Ooh, I goofed here. What was my goof? it's minus f of c. Well, f of c is -1 already, so it's not going to be -1, it's going to be +1. It's going to be minus a minus. So now we can go ahead and simplify. Limit as x approaches 2 of x squared. -5 plus 1 is -4 divided by x minus 2. Well, notice we still can't plug in 2 because we'll get 0 in the denominator. But if we see this part on top, that's the difference of squares. So we can actually factor this out. So it'd be the limit as x approaches 2 of, let's see, x plus 2, x minus 2. That would be the x squared minus 4 factored, all divided by x minus 2. And now, just like what we're doing last unit, this cancels out. So we're left with the limit as x approaches 2 of x plus 2. And then plug it in. So 2 plus 2 is 4. So m tan is 4. So now we have all the information we need in order to plug all of our information into point slope form. So notice our step 1, plug in c to find f of c. We did that in purple. To use m tan to find the slope, we just did that in green. And now we're going to plug in the c f of c into the point slope form. So I'm going to go to orange now. And our point slope form is y minus y1. So y minus y1, this is our point of interest. So y minus a -1, which would be +1, equals m, which is 4, times x minus x1, so x minus 2. And then finally, last step is just solve for y. So to solve, we want to distribute this 4 first, so we're going to have y plus 1 is equal to 4 times x is 4x, 4 times -2 is -8, and then just subtract 1 from both sides. So y is equal to 4x minus 9. And this is the equation of our tangent. Oh, that looks like a 9 now. It should be 4x. You know what I mean. 4x minus 9. Okay, so that's the equation of our tangent line. Now, to find the equation of the normal line, we're going to follow these steps. The first step is we need to find the slope. And notice our first step isn't to plug in c to find f of c, because we already did that. We already have our point of interest. So we're going to go ahead and find the slope. Now, the slope is always going to be the negative reciprocal of m tan. So if you don't remember what a reciprocal is, the reciprocal is you flip the numerator in the denominator. Okay. In this case, remember every number is invisibly over 1, so it'd be 4 over 1 or 1 over 4. Our slope, m normal, I'm just going to put m in for normal, is going to be -1 over 4. That's the negative reciprocal of this. Just change the sign, yeah, so if this was negative, this would become positive, right? Just opposite sign. I should have said opposite sign reciprocal. That's my bad. Okay, so now we need to plug in our c, f of c, and our slope into point slope form. So our point slope form is going to be, let's see here. I guess I'll do it. So y minus y1, well, that's going to be minus a -1, so it's +1, equals -1/4 times x minus x1, and x1 is 2. And that is our function in point slope form. But we need to now solve for y. So I'm first going to distribute this -1/4. So y plus 1 is equal to -1/4 x. Negative 1/4 times x is negative 1/4 x. Negative 1/4 times negative 2 is positive 1/2. I'm going to leave it as 2 over 4 though. And then now I need to move this 1 over. So I'm going to subtract 1 from both sides. But remember, we can only add or subtract numbers that have common denominators to them. So I'm going to rewrite this 1 in terms of fourths, because fourths is what we're interested in combining with. So negative 1 is the same as negative 4 over 4. Right? And then we can combine these two. So y equals negative 1/4 x. 2/4 minus 4/4 is minus 2/4. And that is the equation of our normal. So this is our tangent, and this is our normal. So now what I'm going to do, just for fun, is I'm going to go over to Desmos, and I'm going to graph all these functions for us. The original function, this x squared minus 5, our tangent, and our normal, and we should see something that looks like this. Well, the purple function will look different, but you get the picture. Okay. So let's see here. What am I doing? So this is going to be, so this is our original function here, this x squared minus 5, and our point of concern, well, let's find our tangent. G of x is equal to 4x minus 9. Aha! Let's see if I can kind of flatten this out a little bit. Put it in projector mode. Nice. And then our normal is going to be y equals, let's see, this is the moment of truth here, negative 1/4 x minus 2 over 4. And there we have it. Oh, I know why it doesn't look like it's good, because our axes are not square. There we go. If we were square, there we have it. That's in red is our original function, the blue is the tangent, and the green is our normal line. So let's go over a couple more examples from the worksheet. And again, I'm not going to make you guys do this worksheet. We're just going to do it together. Okay? Change of plans, right? All right. So let's take a look at this one. We have x squared plus 1 equals, and then c is equal to 2. So first step, plug in c to find f of c. So that would be f of 2. So f of 2 is equal to, we'll force, that would be 2 squared plus 1, which is 4. No, 5. So our point of concern is at 2, 5. So now let's use mtan to find our slope. That's step 2. So mtan, let me change colors here. I'll do it in green again. Mtan is equal to f of x, so that's going to be this guy up here, x squared plus 1, minus f of c, which is 5, that's the evaluated one, divided by x minus c, and c is 2, so x minus 2. And I forgot to write my limit, right? I can hear my teachers yelling at me from high school. Let's write it really small. The limit as x approaches 2. There we go. All right. So now let's simplify. Mtan is equal to x squared, and then 1 minus 5 is negative 4 over x minus 2. And this is starting to look familiar, right? I think this is exactly what we had last time, actually. So we can't. Oh, I forgot the limit again. This is strange working from home. This is actually my first video I've made from home, so I'm getting used to it. Okay. So now let's expand this. So mtan is equal to the limit as x approaches positive 2 of x plus 2, x minus 2, that is this factored out. Remember, difference of squares. Then divided by x minus 2, and then this cancels. So we have the limit as x approaches 2 of x plus 2, that's equal to 4. So our slope, our m tan, is 4. So now we can go ahead and plug this into point slope form. Let's see, because we have our point, we have our slope. So our point slope form is y minus y1, so y minus 5 is equal to our slope, which is 4, times x minus x1, so x minus 2, and then simplify. So again, we're going to want to distribute this 4, our slope, so y minus 5 is equal to 4x, 4 times negative 2 is negative 8, and then add 5 to both sides. So y is equal to 4x minus 3. And so this is the equation of our, not our normal. See, I'm all messed up today too. Tangent line. Okay. Now to find the normal, our first step was to find the slope of the normal. Remember, that's just the opposite sign reciprocal of our slope here. So in this case, it's going to be negative 1/4 again. That was same as last time, or as the last example here. And so now we're going to plug in again our point with our new slope, or our normal slope, to find the equation of the normal line. So y minus y1, that's y minus 5, equals our slope, negative 1/4 times x minus 2. And then again, we'll want to distribute that negative 1/4, we want to distribute our slope, so y minus 5 is equal to negative 1/4 x. Negative 1/4 times negative 2 is plus 2 over 4, just like last time. And then now we've got to move over this negative 5, so we're going to add 5 to both sides, but remember, we need common denominators. So y is equal to negative 1/4 x plus 2 over 4, and 5 over 4 would be 20 over 4. So 20 over 4. And then just combine those. So y is equal to negative 1/4 x. 20 plus 2 plus 20 is 22 over 4. And that's it. Yeah. So that's the equation of the normal. All right, so let's go ahead and graph those just for fun. Notice well, I don't know. Yeah, I've only done 2, so I don't know if you've noticed. But the examples from the worksheet I'm doing are the ones where we have a square, or just ones that aren't linear, because the linear can be kind of boring. What am I doing? There we go. Okay. All right, so we're going to go back here, and our new function is x squared plus 1. For x minus 3, and this is going to be negative 4x plus 22 over 4. And again, there we have it. We have our original function in red, blue's our tangent, and then the green is our normal. So let's do one more of these together. Now we have the square root of x minus 1. So again, let's first start off by finding our f of c. So f of c, c is 9, so f of 9 is equal to the square root of 9 minus 1. So f of 9 is equal to, that's 3. So 3 minus 1 is equal to 2. So our point is at 9, 2. Now we need to find our slope. So m tan is equal to the limit as x approaches 9 of f of x. So it's going to be the square root of x minus 1 minus f of c, which is 2, all divided by x minus 9, x minus c. So let's combine that on top. The limit as x approaches 9 of the square root of x minus 3 over x minus 9. And we can't plug in 9 right away, right? So we'll get 0 in the denominator. So we're going to have to do some fancy algebra here. And remember, when we see square roots, we want to multiply by the conjugate. So let's go ahead and try that. Let's see. I'm going to want to multiply both sides by the square root of x plus 3. Remember, that's what the conjugate is. Or not both sides. Well, the top and the bottom. It's just the same thing, but the opposite sign in the middle. So that's going to give us, we're going to want to FOIL this. So x squared times x, or sorry, square root of x times square root of x is x. X squared, or square root of x times 3 is plus 3 square roots of x. Negative 3 times square root of x is minus 3 square roots of x, and this is why we like this so much. Negative 3 times 3 is negative 9, and on the bottom I'm going to leave it just as it is, x minus 9 times square root of x plus 3. And notice these cancel out here in the middle. So what we really have is the limit as x approaches 9 of x minus 9 over x minus 9 times square root of x plus 3. And here we have this cancels, so what we're left with, which is what we wanted, is, oh, getting low there, the limit of x approaches 9 of 1 over the square root of x plus 3. And then we can just plug in 9, right? So 1 over the square root of 9 plus 3 is going to be equal to 1 over 3 plus 3, which is equal to, I'm sorry, I'm kind of getting in there. 1 over 3 plus 3, which is 1 over 6. So this is the slope. This is m tan. Okay. All right. Let's see here. So now we want to plug it into the slope-intercept form. So I'll do that in orange again. So we have y minus y1, so y minus 2 is equal to our slope, which is 1 over 6, times x minus x1, which is x minus 9. And then just simplify, right? We want to distribute this 1 over 6. So y minus 2 is equal to 1/6 times x, which is 1/6x. Then 1/6 times negative 9. Remember, if you have a whole number, you're multiplying to a fraction. Multiply the whole number to the top, and then see if you can divide by the bottom. In this case, it's just going to be negative 9/6. And then we want to move that negative 2 over. So plus 2. But remember, we need the common denominator, so y equals 1/6 x minus 9 over 6. The 2 we can turn to 12 over 6. So that is equivalent to 2. And then combine like terms. So y is equal to 1 over 6x. Negative 9 plus 12 is plus 3/6. And that is the equation of the tangent line. Then finally, to find the equation of the normal line, we're going to do the same thing, but we need to find the slope of the normal. So m sub n is, let's see, the negative, or the opposite sign reciprocal of 1/6 is going to be negative 6. That's nice that we have a whole number. All right, so now we plug that in this into the point slope form. So y minus 2 is equal to negative 6 times x minus 9. and then simplify. So y minus 2 is equal to negative 6 times x is negative 6x. Negative 6 times negative 9 is, geez, positive 54. And then add 2 to both sides. So y is equal to negative 6x plus 56. All right, just for fun, let's go ahead and graph that one. So our original function was the square root. Oh, and if you're interested in how to, I mean, you can go down here and find the square root right there. But if you want a shortcut in Desmos, you can just type in SQRT, and it automatically goes to a square root. Pretty cool. So we have x, and then minus 1. That's our original function. Oh, I want to get rid of this though. And then our tangent is 1 over 6x plus 3 over 6. And then the equation of our normal is negative 6x plus 56. And let's see. There we have it. In red is our original function, the blue is the tangent, and the green is the normal. So again, no need to do the worksheet today. We'll do something tomorrow. It'll be more straightforward than this. I apologize that the original videos I sent were confusing. So yeah, that's it. Have a good day. Bye. Oh yeah, so don't worry about turning in the assignment for today.